have 1.6 terawatts of photovoltaic power installed worldwide, and last year 400 gigawatts were added globally. So in Germany alone there was a 100% increase from 2022 to 2023. And weight of the modules, the need for critical raw materials, dependency on other countries for production, organic photovoltaic panels. They are made of carbon, are very sustainable, do not require critical raw materials and can be installed almost anywhere because they're extremely light. Today we will clarify how this type of photovoltaics works. 92% of all solar cells worldwide are silicon solar modules. Large quantities, and due to some properties that we will discuss in more detail in a moment, it is perfect for producing electricity from sunlight. They typically achieve an efficiency of between 17 to 22%. Tandem solar cells with several layers, for example, an efficiency of approximately 32% can be achieved. Although silicon is the second most common chemical element on Earth, China dominates all stages of the silicon production value chain with a market share of over 80%. What is so striking about this is that around 2010 there was actually still now prices from China are so low that it is extremely difficult for Europe to rebuild its own solar industry. The PV industry consumes approximately 1,500 tons of silver per year worldwide, which corresponds to just under 6% of the total production in 2020. Germany alone already produces 10,000 tons of scrap metal from PV every year, and to as much as 1 million tons of photovoltaic scrap metal. The individual components are simply glued together extremely strongly to separate them cleanly. But that is only a tenth of the suitable commercial roofs in Germany. At least that is the estimate of the German Solar Industry Association. Many bureaucracy hurdles, which also vary from state to state, weight is also a major factor. Often the roof load is insufficient. Depending on the type of module, they weigh between 10 and 25 kilograms. 300 kilograms for a single family home and around 500 kilograms for larger buildings. In terms of the basic principle, organic solar cells are no different from crystalline solar cells. Both convert light into electrical energy through the photovoltaic effect. Silicon solar cells have two layers. Phosphorus is added to the upper layer, known as the N layer, which gives the layer freely moving electrons. Boron is added to the lower layer, the P layer. This creates holes that are positively charged, so to speak. A neutral boundary layer, the PN junction, is created at the point where the two layers meet. The electrons from the N layer now pass through this junction into the holes in the P layer. This charges the edges of the layers. The edge of the N layer is then positive and the edge of the P layer negative. When light waves, so photons, strikes a solar cell, this charge distribution is reversed. The electrons are excited by the photons and are released from their bonds. A constant movement creates a flow of electrons that can be. Solar cells have a donor layer and an acceptor layer. These materials are chosen to complete each other well. The donor releases electrons while the acceptor absorbs them. But when light hits the cell, energy is absorbed, creating bound pairs of electrons and so-called holes. These pairs are called excitons, and the holes represent the absence of electrons, so to speak, and are therefore positively charged. The electrons do not move alone here, but together with the positive charge carriers or holes. At the interface between the donor and the acceptor, the electrons are captured by the acceptor, while the holes remain in the donor. This separates the charges. The charge carriers move to the electrodes by hopping. The anode, usually a transparent conductive layer, collects these holes, while the cathode, a metal layer, collects these electrons, which in organic solar cells consist of hydrocarbon compounds. These can be conjugated polymers, for example, which are organic materials that usually contain, such as the one you see here. This is called a conjugated structure. The special thing, they contain pi electrons. These are less tightly bound and can therefore move easily along the polymer chain. And production is very easy and very inexpensive. Few hundred nanometers thick so that the charges can reach the electrodes quickly enough. which are 100 times thinner than a human hair, are vapor deposited onto a carrier film. Flexible and is often produced as a kind of film. Production is also very environmentally friendly, and the lower weight means less scrap is generated. The company is called Heliatech, and this film can be easily added almost everywhere and used directly thanks to an integrated connection cable. Such a film element weighs less than 2 kilograms and can be bent up to 50 centimeters. Transparent elements. This makes it even possible to attach them to window panes or integrate them into sun protection slats. Although for solar energy systems has a project in which organic solar cells are to be used in agriculture. Many plants are grown under foil to protect them from heavy rain, hail, or even too much sun. A smart alternative to plastic foil could be translucent organic photovoltaics, which also protect the plants from the weather and generate electricity at the same time. Organic solar cells for indoor use. And by the way, there's even a project by the Federal Ministry of Economic Affairs and Energy in Germany to improve the efficiency of organic solar cells indoors. To this end, a company has already coupled sensor systems and intelligent charging electric buildings such as hospitals, police stations, or research and educational institutions. The lights are on up to 24 hours a day, and practical here due to the weight and transparency of the cells. Radio data loggers, remote controls, sensors for temperature, humidity, CO2, or portable electronics. Now comes the big hurdle. This is the part in the video where we look at the 15.8%, 30.2% has already been achieved, at least more than that of silicon cells, because they are attacked by UV light, oxygen, and moisture. At the moment, huge. Incredibly huge on a larger scale. So this is not such a big hurdle, to be honest, with more research. So let's come to a conclusion here. Silicon cells have a 20 to 30 year head start in terms of development, so to speak. But the two types of solar cells are not in competition with each other. The production of silicon solar cells will probably always be cheaper in China than in Europe or the US. Have 1.6 terawatts of photovoltaic power installed worldwide, and last year 400 gigawatts were added globally. So in Germany alone there was a 100% increase from 2022 to 2023. And silicon cells have a 20 to 30 year head start in terms of development, so to speak. But the two types of solar cells are not in competition with each other. The production of silicon solar cells will probably